In the vast universe where stars quietly burn for billions of years, there are distant galaxies drifting through the deep darkness of space. Each galaxy is like a colossal city of light, containing hundreds of billions of stars, immense clouds of gas and mysteries that humanity is still trying to understand. When we look up at the night sky, the faint light from the stars we see may have begun its journey millions or even billions of years ago. This means that when we observe the universe, we are also looking backward into a very distant history of time. Welcome to Stories for Sleep, a place where stories about science, the universe, and the human mind are told in a slow and gentle rhythm, so you can listen and relax before falling asleep. In tonight's video, we will travel together through distant galaxies, exploring how they formed, how they move through the universe, and the deep mysteries they continue to hold. If you enjoy these quiet journeys through science and space, you can subscribe to the Stories for Sleep channel so you won't miss future stories. And now, take a slow breath in. Relax your mind as we begin our journey into the distant galaxies of the universe. When night falls and the sky grows quiet, people throughout history have looked up at the small points of light above them and wondered, what kind of universe do we live in? The stars visible to the naked eye are only a very small part of a much larger picture. Hidden in the darkness of space are distant galaxies, enormous structures containing hundreds of billions of stars, vast clouds of gas, and mysterious black holes. The light from many of these galaxies began traveling toward us millions, even billions of years ago, long before our Earth took the shape we recognize today. So whenever we look into the universe, we are not only looking across space, we are also looking across time. What is remarkable is that although these galaxies lie at distances almost impossible to imagine, they continue to hold a special fascination for the human mind. Perhaps this is because when we gaze into the deep universe, we are also looking at something within ourselves. The Swiss psychologist Carl Gustav Jung once suggested that human beings are drawn to the great symbols of the cosmos. These symbols reflect the quiet questions that live deep within the mind. Where did we come from? Where are we within the vast picture of existence? And what might lie ahead in the long journey of time? Tonight we will not rush to answer all of those questions. Instead, we will take a slow and quiet journey through deep space, exploring distant galaxies drifting through the universe. We will look at how galaxies form, how they move through the great ocean of space, and the mysteries scientists are still trying to understand. But more importantly, this journey is not only a scientific exploration, it is also a moment for the mind to relax, to feel the vastness of the universe and the quiet peace of the night. So as you listen to this story, allow yourself to relax a little. Imagine that you are drifting slowly among the stars, where everything moves gently and time seems to stretch endlessly. And as we travel deeper into distant galaxies, you may begin to discover something surprising. The universe is not only a place filled with mystery, it is also a gentle story that humanity has slowly been learning how to listen to. A journey to the most distant galaxies. When night falls and the sounds of the world slowly fade away, the sky above us begins to feel deeper, as if it opens an ancient doorway into the universe. For thousands of years, people have looked up at those small points of light and wondered, how far away are those stars? And what lies beyond the sky that our eyes cannot see? Yet the remarkable truth is that what we see is only a tiny part of a much larger picture. Hidden within the darkness of space, a distant galaxy, enormous structures containing hundreds of billions of stars, vast clouds of gas and mysterious black holes. Each galaxy is like a great city of light drifting quietly through the endless ocean of the universe. When we look at these galaxies, we are not only looking across distance, we are also looking across time. The light from some of the farthest galaxies began its journey billions of years ago, when the universe itself was still young. This means that every photon of light reaching our eyes carries an ancient message, telling a story from an era when Earth itself did not yet exist. And within that realization, a quiet and beautiful feeling emerges. The universe is not only a distant place, it is like a vast book written in light. When astronomers turn their powerful telescopes toward the deep sky, they begin to realize that the universe contains far more galaxies than anyone once imagined. Each galaxy has its own shape, its own structure, and its own history. Some galaxies are spirals with luminous arms curling like rivers of light. Some are ancient elliptical galaxies where old stars shine quietly. Others appear distorted and irregular, as though they have recently passed through immense cosmic collisions. But what astonishes scientists most is their distance. Some galaxies are so far away that their light has taken more than 13 billion years to reach Earth. This means that when we observe them, we are seeing the universe at a moment very close to the dawn of existence. This is what makes the exploration of distant galaxies so extraordinary. It is not only a survey of space, it is a journey through the history of the universe. And when humanity began to realize this, a gentle but profound thought appeared. We live in a universe where the past is still sending its signals into the present. From the perspective of depth psychology, the fascination humans feel toward the universe may not be accidental. The Swiss psychologist Carl Gustav Jung once suggested that human beings are naturally drawn to the great symbols of the cosmos. When we look at distant galaxies, we are not only observing physical structures in space, we are also confronting ancient questions. Where did we come from? How did the universe begin? And what is our place within this immense cosmic picture? Distant galaxies are like vast mirrors reflecting human curiosity. They remind us that although daily life may feel small and immediate, the human mind always has the ability to reach farther across space and time in search of meaning. And perhaps that is why looking at the night sky often brings a special sense of calm. Within the vastness of the universe, the small worries of life begin to feel lighter. So the journey to the most distant galaxies is not only a scientific story, it is also a journey of imagination and reflection. When we think about galaxies drifting silently through deep space, we begin to sense the slow rhythm of the universe. Stars are born, they shine for billions of years, and eventually they fade. Galaxies collide and merge, forming new cosmic structures over immense stretches of time. Compared with that rhythm, a human life is only a brief moment. Yet that moment contains something extraordinary, the ability to understand the universe. We are small beings, living on a small planet, yet we can look up and realize that the light touching our eyes began its journey long before we were born. And as you listen to this story in the quiet of the evening, you might imagine yourself drifting slowly among the stars. No noise, no urgency, only the ancient light of distant galaxies passing gently through space. And in that moment, the universe no longer feels unfamiliar. It becomes a gentle story humanity has begun to learn how to listen to. Looking far is also looking into the past. When we look up at the night sky, something that seems simple actually hides a remarkable truth. We are not truly seeing the universe in the present. Light needs time to travel. and in the vastness of space, that time can be incredibly long. Light from the moon takes a little over 1 second to reach Earth. Light from the sun takes about 8 minutes, but light from distant galaxies may require millions or even billions of years to arrive. This means that when astronomers observe very distant galaxies, they are not seeing them as they exist today. They are seeing them as they existed long ago. A galaxy 1 billion light-years away appears to us exactly as it was 1 billion years in the past. Because of this, the universe becomes a kind of natural time machine. Each distance in space corresponds to a moment in cosmic history. So when scientists aim their telescopes farther into space, they are also looking deeper into the early history of the universe, like turning the pages of an ancient book written in light. This principle allows astronomers to reconstruct the timeline of the universe. Galaxies closer to us show the universe at a later stage when cosmic structures have stabilized and generations of stars have already lived and died. But galaxies at extreme distances reveal a much younger universe. In the deepest images of the sky, astronomers observe small, irregular galaxies that appear chaotic and unstable, signs of a universe still forming. By comparing galaxies at different distances, scientists can trace how galaxies have evolved over billions of years. It is similar to studying photographs of a city taken at many points in its history. Through these comparisons, astronomers see how the universe developed, from primordial gas clouds to young galaxies bursting with star formation to mature galaxies where ancient stars shine quietly. The universe is no longer a static picture. It becomes an unfolding story across time. Deep field images of the sky. Sometimes astronomers do something surprising. Instead of pointing their telescopes toward bright and familiar objects, they select a tiny patch of sky that appears completely empty. Then they allow the telescope to stare at that region for many hours, sometimes for days, collecting faint photons that quietly drift through space. At first, the image appears almost completely dark. But slowly, as light accumulates, something extraordinary emerges. Tiny points of light appear. Not individual stars, but distant galaxies, each containing billions of stars. These images are known as deep field observations. And what amazed scientists most was this: in a region of sky so small it could be hidden behind a grain of sand held at arm's length, there are thousands of galaxies. This discovery revealed that the universe is not mostly empty. Instead, it is filled with galaxies almost everywhere we look. Gravitational lensing. When gravity bends light, in the first, silent depths of space, there exists a phenomenon both strange and beautiful. Light, which we often imagine traveling in straight lines, can sometimes bend. This happens when light passes near extremely massive objects, such as clusters of galaxies. According to the theory of gravity, mass does more than pull on matter. It also bends the fabric of space and time itself. When space becomes curved, the path of light changes. As a result, light from a distant galaxy may bend as it passes a massive cluster in front of it. Sometimes we see long arcs of light stretched across the sky. Sometimes a single distant galaxy appears as multiple images. And in rare cases, the light forms a perfect circle known as an Einstein ring. This phenomenon is called gravitational lensing. The concept originates from the work of Albert Einstein, whose theory of relativity showed that gravity can curve space. For astronomers, gravitational lensing acts like a natural telescope, magnifying galaxies that would otherwise be too distant and faint to see. The colors of galaxies and redshift. When we observe galaxies far across the universe, their light often appears unusually red. This phenomenon is known as redshift. As the universe expands, the space between galaxies stretches, and as space stretches, the wavelengths of light traveling through it stretch as well. This causes light to shift toward the red end of the spectrum. The idea that the universe is expanding was confirmed in the early 20th century by Edwin Hubble. He observed that most galaxies appear to be moving away from us. Even more remarkably, the farther a galaxy is, the greater its redshift. This discovery revealed that the universe itself is expanding, like an enormous cosmic fabric slowly stretching over time. Through redshift measurements, astronomers can estimate both the distance and age of galaxies. Galaxies with greater redshift appear as they existed earlier in cosmic history. In this way, scientists can map the universe in 3 dimensions across space and time. And when we reflect on this in the quiet of the evening, the idea carries a gentle beauty. Light from distant galaxies began its journey long before Earth existed. For billions of years, it traveled across, expanding space, slowly stretching toward the red. And finally, after that unimaginable journey, it arrives at our telescopes. In that moment, the past of the universe becomes visible in the present. And perhaps that is what makes the night sky so quietly magical. It is not just a view of space. It is a view of time itself, flowing softly across billions of years in the silent depths of the cosmos. Collisions between galaxies. When we imagine the universe, many people picture a quiet expanse where galaxies drift silently through the endless darkness of space. Yet on the vast scales of the cosmos, things are not entirely so still. Galaxies are constantly moving, drawn by the gravitational pull of enormous structures around them. In the early universe, when the cosmos was much smaller than it is today, galaxies were closer together. The distances between them had not yet been stretched so far by the expansion of space. Because of this, encounters between galaxies were far more common. When 2 galaxies begin to approach one another, gravity slowly draws them into a long and gentle dance that can last hundreds of millions of years. Unlike violent collisions between planets, galaxies rarely crash together in a sudden act of destruction. Instead, they pass through each other, stretching one another's shapes and gradually beginning a slow but transformative process of merging. As 2 galaxies draw nearer, their gravitational forces begin to distort each other's structures. Stars within the galaxies are pulled outward into long streams called tidal tails, stretching hundreds of thousands of light years into space. These streams of stars resemble soft rivers of light curving through the darkness of the cosmos. At the same time, vast clouds of gas within the galaxies begin to collide and compress. When gas is squeezed tightly enough, it can collapse under its own gravity and give birth to new generations of stars. This process leads to what astronomers call a starburst periods, when millions of new stars form within a relatively short cosmic time. These regions of star formation often shine intensely, making colliding galaxies appear brighter than usual. In a quiet paradox, galactic collisions do not simply destroy old structures, they also ignite new stellar life. Over time, after passing through one another several times and gradually losing orbital energy, the 2 galaxies may slowly merge into a single larger galaxy. This process can take billions of years, and the final result is often a completely new galaxy, with a structure very different from the 2 that came before. Many giant elliptical galaxies observed today are believed to be the result of multiple mergers in the distant past. Even our own galaxy, the Milky Way, is not a perfectly stable structure. Observations suggest that it is slowly absorbing smaller dwarf galaxies around it. In the far future, the Milky Way itself will undergo a major event when it collides and merges with the Andromeda Galaxy. This cosmic encounter is expected to occur about 4 to 5 billion years from now. Together they will form a new, larger galaxy. Yet even then, the distances between stars are so immense that the chance of two individual stars colliding directly is extremely small. When we think about these galactic collisions in the quiet of night, we begin to sense a particular rhythm of the universe. These immense events unfold so slowly that they almost resemble the drifting of enormous clouds passing through one another in space. Carl Gustav Jung once suggested that many great symbols of the universe reflect deep processes within the human mind. Perhaps galactic collisions carry a similar meaning. They remind us that change and transformation are not always endings. Sometimes, when two older structures meet and blend together, something new and larger can emerge. In the universe, galaxy collisions are not merely chaotic events. They are also moments of creation where new generations of stars begin to shine in the deep darkness of space. And as you listen to this story before sleep, you might imagine that somewhere in the universe, two galaxies are slowly drawing closer together, beginning a dance among the stars that will last billions of years. The colors that reveal a galaxy's activity. When we look at images of galaxies in the universe, one of the first things that captures our attention is their color. Some galaxies glow with a gentle blue light, like the brilliance of young stars burning brightly. Others carry a deep red tone, as if quietly telling the story of stars that have lived for billions of years. In astronomy, color is not merely visual beauty. It is a language of light that allows scientists to understand what is happening inside distant galaxies. Blue light often comes from young, hot, massive stars. These stars burn intensely, but live relatively short lives by cosmic standards, only a few million years. Therefore, when a galaxy appears strongly blue, it suggests that vigorous star formation is taking place within it. Clouds of gas in the galaxy are collapsing, forming new stars whose blue light illuminates the entire galaxy. In contrast, galaxies that appear red are usually places where most of the stars have grown old. The young, hot stars have faded away, leaving behind smaller and cooler stars that emit a softer red light. This indicates that star formation within those galaxies has slowed significantly or nearly stopped. Large elliptical galaxies often display this reddish color. They resemble ancient cities of the universe, places where old stars still shine quietly, but very few new ones are born. For astronomers, the contrast between blue galaxies and red galaxies helps reveal the evolutionary history of galaxies. Blue galaxies represent a dynamic stage of the universe, when gas is still abundant and stars are forming actively. Red galaxies reflect a more mature stage, when gas supplies have diminished and older stars dominate. To study galactic colors accurately, astronomers do not rely solely on what the human eye can see. Instead, they use specialized filters on telescopes. Each filter allows a particular portion of the light spectrum to pass through, such as blue, red, or infrared light. By photographing the same galaxy through several different filters, scientists can analyze how light is distributed across wavelengths. From this information, they can estimate the average age of stars within the galaxy and determine how rapidly new stars are forming. These measurements allow astronomers to reconstruct the life story of galaxies, when star formation began, when powerful starbursts occurred, and when galaxies gradually became quieter over time. In this way, the color of a galaxy becomes a powerful tool for reading the rhythm of cosmic evolution. And in the calm quiet of evening, there is a gentle beauty in this idea. Blue galaxies resemble youthful gardens where new stars bloom like luminous flowers. Red galaxies resemble ancient forests, where the light of old stars glows softly in the deep darkness of space. Carl Gustav Jung once observed that human beings often perceive symbols of life and time within the images of the cosmos. Perhaps the colors of galaxies carry such meaning as well. They remind us that the universe, like life itself, passes through different stages, moments of youthful energy and periods of quiet maturity. And as you listen to this story before sleep, you might imagine that somewhere in the universe, billions of galaxies shine with different colors, each color telling a story about time, the life of stars, and the long journey of light through space, the rapid growth of galaxies in the early universe. When we imagine the universe today, we often think of large and stable galaxies, like the Milky Way, enormous systems containing hundreds of billions of stars moving along familiar orbits. But if we travel back to the earliest ages of the cosmos, the picture looks very different. During the first few billion years after the universe was born, galaxies were smaller, more chaotic, and still forming. They resembled young islands of light emerging within the dark ocean of space. These early galaxies were much smaller than the mature galaxies we see today, yet they were far from still. They were constantly changing, growing, and merging with one another. Modern telescopes that peer deep into the universe reveal these young galaxies everywhere, tiny points of light, just beginning their stories in the history of the cosmos. One reason galaxies grew so quickly in the early universe was the abundance of gas. After the first atoms formed, the universe contained vast amounts of hydrogen and helium, the basic ingredients for star formation. Enormous streams of gas flowed continuously into young galaxies, like invisible rivers feeding cities of light under construction. As gas accumulated inside galaxies, it collapsed under gravity and formed new stars. During this era, the rate of star formation could be far higher than it is today. Young galaxies resembled blooming gardens where millions of stars formed within bright clouds of gas. Another key factor behind the growth of early galaxies was the merging of galaxies themselves. Because galaxies were closer together in the early universe, encounters between them happened frequently. When two small galaxies approached one another, gravity drew them into a slow cosmic dance, lasting hundreds of millions of years. Eventually, they could merge into a larger galaxy. This process not only combined the stars of both galaxies, but also mixed their gas and dust, triggering additional waves of star formation. Through countless mergers like these, many of the large galaxies we observe today were built from hundreds or even thousands of smaller systems in the distant past. The young universe therefore resembled a vast construction site where galaxies continually grew through encounters and mergers. When we reflect on this early stage of the cosmos, we sense a special rhythm of formation and transformation. Young galaxies were not perfect structures from the beginning. They began small, chaotic, and constantly changing. Yet, over time, through the accumulation of gas and gradual mergers, they became the enormous and stable systems we see today. Carl Gustav Jung once suggested that many images in the universe reflect deeper patterns of growth and transformation. Perhaps the history of galaxies carries a similar meaning. It reminds us that great structures often begin with very small beginnings. And as you listen to this story before sleep, you might imagine that somewhere in the distant universe, young galaxies are still continuing their journey, quietly growing within the endless ocean of stars.